Welcome to an overview of the scientific metrics that are calculated using the KinetiGait software. KinetiGait provides a scientific, three-dimensional analysis of a runner's overall gait pattern and calculates several metrics including stride length, stride rate, and run speed. One of the most useful metrics is 3D variance, and this short video will provide some more detail about this scientific measure. KinetiGait is accurate to 1.5 millimeters and collects stride data in full 3D. These collected strides are then compiled into one representative gait cycle. The software scales the runner by height and then time normalizes the gait cycle to match the scientific norm. The far left of the variance graph indicates right touchdown, with right toe off occurring approximately here. The first flight phase occurs in the middle section of the graph, with left touchdown and toe off shown by the next two markers respectively. This final section represents the second flight phase of the gait cycle, which then cycles back to right touchdown. In order to help you make evidence-informed decisions about the overall gait pattern, KinetiGait maps the runner, seen here in green, onto a scientific morphometric norm, comprised of all runners in our research database, seen here in white. 3D variance is a mathematical and scientific measure of how much the individual runner differs or varies from the norm. The additive differences in the three-dimensional points that make up the runner and norm are compared to one another and variance is calculated. By comparing each frame of data, KinetiGait calculates the variance for the entire gait cycle and allows the user to specifically identify the phase of gait, or exact point in the gait cycle, when variance is highest and differs the most. By doing so, you can make accurate measurements of the individual runner and evidence-informed decisions about what aspect of their gait may be related to injury treatment or prevention. KinetiGait can also help coaches make decisions about how an individual runner can change their gait pattern for improved efficiency. KinetiGait provides an interactive 3D viewing window to allow an in-depth analysis of the subject's gait. Playback can be stopped, rotated, and reviewed frame by frame in order to focus in on key moments during the gait cycle. For example, when variance peaks, or in other words, when an individual varies most from the scientific norm. For this runner, you can easily see that their 3D variance pattern is highest when their left foot is on the ground and lowest when the right foot is in contact. In other words, when their left foot is on the ground, their overall gait mechanics vary, or differ the most, as compared to the scientific norm. For this runner, analysis of the variance graph allows us to hone in on specific important gait characteristics. It is apparent that the peaks in variance occur during the stance phases for both feet. By keying in on this information, we can link this heightened variance to excessive forward trunk lean and a high stride rate for this particular speed. By further examination of the point cloud, we also notice this runner's excessive vertical oscillation as an additional contributing factor to their overall variance compared to the scientific norm. Overall, this runner would benefit from some simple gait retraining drills and a slight change to their stride rate. However, further clinical evaluation would be necessary to help understand why they exhibit a higher than normal vertical oscillation. One possibility could be a reduced strength of the primary weight acceptance musculature, such as the gluteals, quadriceps, and trunk extensor muscles. The 3D variance plot can also help to visualize side-to-side asymmetries. Notice the increase in 3D variance near the end of stance phase for the left foot. There is significantly more hip extension to compensate for the reduced right arm swing. As well, the left foot exhibits a crossover foot strike pattern, which places increased strain on the IT band and requires greater trunk rotation to occur throughout left stance in preparation for toe off. Future software updates, due out in the fall of 2017, will include the ability to perform a walking gait analysis, the ability to compare an individual to gender and sport-specific subgroups, as well as the ability to compare the individual to their own baseline data in order to evaluate rehabilitation or gait retraining progress. Look back to our website or follow the Running Injury Clinic on Facebook to keep up with these updates and to read more about our world-class research.